Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about Gaussian random process and Poisson random process. So first we are going to discuss about Gaussian random process concept. And what is Gaussian random process? In my previous videos, in previous chapter, we have already discussed about concept of Gaussian random variables and the concept of Poisson random variables. So now here we are going to discuss about Gaussian random process and Poisson random process. First one is Gaussian random process. Consider a continuous random process x of t. Let capital N random variables x1 is equal to x of t1, x2 is equal to x of t2, x3 is equal to x of t3, and so on. Xn is equal to x of tn. So there are n random variables at time instance t1, t2, t3, and so on tn. We define okay, n time instance respectively. And what is a random process? Random variable is a function of time. It's called as a random process. So capital X is the random variable. That random variable X is a function of time is called as a random process. And capital X is a Gaussian random variable. It varies with function of time. It is called as Gaussian random process. So now here X of t is the Gaussian random process. If these random variables are jointly Gaussian for any capital N is equal 1, 2, 3 and so on, and at any time instance, the time instants are t1, t2, t3 and so on tn, then the random process x of t is called a Gaussian random process. The joint density function of a Gaussian random variable is given as fx of x1 comma x2 comma x3 and so on xn comma t1 comma t2 comma t3 and so on tn is equal 1 divided by square root of 2 pi whole to the power of n determinant of cx matrix into exponential of minus 1 by 2 into x minus x bar cx inverse x minus x bar. Here x bar is the mean value of the random process. X bar is the mean value of the random process. So fx of x1 comma okay. Where x bar is the mean value of the random process, that is x bar is equal expectation of x of t, and cxx is the covariance matrix and its elements are covariance matrix elements are c suffix I is equal expectation of xi minus xi bar into xk minus xk bar. So xi bar is the expectation of xi and xk bar is the expectation of xk. So mean value of the random process xi and mean value of the random process xk. C suffix I is the autocovariance of x of ti and x of tk. Also by expanding the above expression, the above equation, we can get Cxx of Ti comma Tk is equal to Rxx of Ti comma Tk minus expectation of x of Ti into expectation of x of Tk. So this equation is already explained in the concept of the autocovariance function of the random process, where Rxx of Ti comma Tk is the autocorrelation function of random process x of t. If the process is Whiteson stationary, then it should satisfy the following conditions. So that conditions are mean value will be constant, that is expectation of x of t is a constant value, and second condition is the mean autocorrelation function and autocovariance functions will be depend only on time difference and not on absolute time. So that is Cxx of Ti comma Tk is equal Cxx of Tk minus Ti and Rxx of Ti comma Tk is equal Rxx of Tk minus Ti. So this is the concept of Gaussian random process. Next, we are going to discuss about Poisson random process. So the Poisson random process x of t is a discrete random process which represents the number of times that some event has occurred as a function of time. So Poisson process describes the number of times that some event that has occurred as a function of time where time events occurs at random time. To describe the Poisson random process, let x of t represents the number of events occurrence with time. Then x of t has integer valued non-decreasing sample functions. So that is shown in figure. That is shown in this figure. This is the Poisson counting process figure. In these functions, a single event occurs at a random time. Counting the number of occurrence with time is a Poisson process. It is therefore also called a counting process. So which is shown in that Poisson counting process sample function shown in this figure. There are different time instants T1, T2, T3 and so on Tn. So the important conditions for a Poisson random process are x of 0 is equal to 0, and second condition is only one event occurs in any instant of time, that is in infinitesimal time interval. So this is the concept of Poisson random process.